Okay, well, this is the last lecture of the course, so good job for um, getting through it. That's cool. Sorry I wasn't able to have my handy um, tuning fork earlier in the class, but at least it got to make an appearance before we were totally done with the course, right? So, um, all right, and hopefully you've enjoyed the class too. Uh, I had fun teaching it, but I like this stuff, right? Hopefully, I got you into it as well. All right, so this is our last talk again about speech perception. This time, we're going to look at a couple different theories of speech perception. Basically, we're going to talk about two, and I'm going to say that one of them is stupid and the other one isn't. But so I'm looking forward to that. We're going to talk about the motor theory and the general auditory theory. So, the motor theory of speech perception kind of comes out of that weird finding that we talked about of categorical perception, right? So, just to really quickly recap, a B, no matter a B, it can be voiced in quite a few different ways, and we still perceive it as a B, as an almost perfect B, until it gets to a certain place, and then all of a sudden it's a D. With voice onset time, we can hear a B, and we can cut off the VOT quite a lot until it becomes a P. And then all of a sudden it becomes a P. There's nothing in between. We don't hear like some sort of B-P hybrid. We hear B, and then we hear P. So motor theory comes from that categorical perception. And it comes out before the natural regularity idea was developed. That came about in 89, sometime from 89 to 94 is when people were writing about natural regularities. And the two people who wrote about natural regularities were Albert Bregman and also Bill Yost, who teaches at ASU. I guess he's semi-retired, but he's still around. So, but he was one of the two main people that were pushing the natural regularity idea. It also comes from this idea that speech is a special thing. If you had 367 with me, you know that I do not in any way think that speech is special at all. I mean, it's really cool. It's special in that it allows us to communicate well, and it really is the crux of our communication. But I don't think it's a special perceptual case. I don't think it's a special neural case. There's nothing about it that I think is special. I think it's a thing that our bodies are able to do, and then the perceptual and motor characteristics and everything that goes along with it just kind of developed to work with that. I mean, if speech was special, you could say that running was special, and we evolved to be like, oh, I can run, so we evolved like specifically to run. It's ridiculous. I mean, I think we realize that we can run and we work with it. Certainly, bodies evolved to do things, but not in this specific way. Running is probably a stupid metaphor for that, because we probably did evolve to run. I can't imagine a old proto-human not being able to run. They'd get eaten by something, a tiger, like Joe Exotic, and then not that in that one scene he almost got eaten by a tiger. Anyway, but they probably wouldn't, live, and they wouldn't be able to pass on their genetic information. So then probably we did evolve to run. But anyway, I don't think we evolved to speak. I think speech is a thing that happened. Maybe once it was there, it contributed to the success of the organism, but it wasn't something that it's not special in that way. Anyway, so it comes from the idea that speech is special. It's a unique case. It's different than everything else. It's a really special thing. And then it also goes into saying that speech is perceived categorically because we produce it categorically. So Categorical production, the fact that I can go buh and puh, but I can't do something in the middle where I go buh, 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 puh, like that, makes categorical perception. So, remember though, this guy, he was a little afraid to come out there for a second. That guy. Remember that guy? Well, you know, we have color vision, and we perceive it categorically, but we don't produce color, right? So that seems odd to me that that just because we can speak means that we perceive language categorically, because we don't make color. So that's kind of strange. We know that changing the voice onset time shifts from buh to puh. We saw that in the last lecture. We know that we can't also change those. We can't go from buh to puh. Okay, so this is all true. And since we can produce only one or the other, the perceptual system has to make the information fit one or the other. This is the motor theory again, right? But if it's true that the motor production leads to perception, then that means that categorical perception is a result of learning speech. You can't perceive something categorically before you learn how to say it, right? If the motor production gives you categorical perception, then you have to learn how to speak first. Also, categorical perception would be innate, not something that, we'd start out with it, and it wouldn't develop over time. And also, it would only be unique to speaking animals, us and a few others. But we actually see that we have evidence that categorical perception is around before we learn how to speak. Babies are tuning out non-canonical sounds, sounds from other languages, before they can even talk. So as soon as they come out of the womb, they can understand all phonemes of all languages. Probably phonemes that aren't used in any language. They could differentiate between these. You can have them listen to, I can't do this, but I know in Hindi, there are two different kinds of ma and ma, right? It sounds the same to me. I probably didn't say them correctly. Maybe one of you, if you know it, send me a video or a sound clip of you saying it, because I'd love to put it on this. But anyway, there's two different mas, or mas, something. And English speakers just cannot hear the difference, right? But obviously, Hindi speakers can. And babies, when they come out, can tell the difference. They're English speakers. They're born to English-speaking parents who have spoken English since the 1600s or before. And yet the babies could understand all the differences between the phonemes. But before they even say their first words, they stop responding to those two different kinds of ma. Now they're locked into English phonemes, and that's all they respond to. They no longer differentiate between ma and ma. They think it's just one ma, and that's it. So they've come up with categorical perception before they can speak. So that kind of invalidates that first point there. And another thing is that we've actually seen categorical perception in intelligent animals that have no way of speaking. Dogs, dolphins, they've all got categorical perception. You can teach them that buh is, let's go for a walk, and puh is, you did something very wrong. And you can play the buh puh continuum, and they'll be excited, and then all of a sudden, oh, what? And they'll kind of cower and slink away from you. So they have categorical perception too, but they don't have speech. Not even close. So maybe categorical perception isn't special. Maybe it's just what our brains do. It seems like stimuli that are reinforced become more similar. So your parent says, any word is really reinforced. But let's say, let's use the dog example. It's a little easier, I think. So we're going to go out. The dog likes to go out. We say, "Bah." And then we go out again another day, and we're a little tired, or maybe we have a sore throat, and we say, "Bah." And it's a very different "bah." The "bah," the voice onset time of the "bah" is totally different. And the dog at first might not realize that that "bah" is the same as that "bah." Over time, you repeat "bah" to it when you go for a walk, and it starts to pair up. "Bah" means we're going for a walk. And it knows that there's a range of values of that voice onset time that are essentially the same. It learns that things don't, that those certain voice onset times are meaningless. Those differences are meaningless. But if you're also telling it "pa" when it does something bad, "pa," then it learns that there is a voice onset time that is important. It knows that "ba" is go for a walk. It knows that "pa" is something very bad. And it knows that the range of voice onset times here is not important. The range of voice onset times here is not important. But the range of voice onset times here is important. Very important distinction for the dog between "ba" and "pa." So anyway, it seems that stimuli that we've reinforced become very similar neurally and perceptually. And stimuli that are reinforced as very different become more different neurally and behaviorally. This is how automated speech and handwriting recognition work as well. We can build neural networks for computers that look at a 2 written like this, a 2 written like this, and a 2 written like this. And at first, it might know that, okay, it's trained to look at this 2. And what they do is they have it read these numbers, and it says, "I think this is a 2." And you tell it, "Yes." And then it looks at this, and it says, "I think this is a 2." And you tell it, "Yes." And it looks at this, and it says, "I don't know what this is. I think it's a 7." And you say, "No." And so then it updates what it thinks that this could be. You tell it it's a 2. And so the neural network is like, okay, so 2s can look like this, but they can also maybe have some differences. And maybe it thinks that this is kind of an error, but it's like okay with this type of error. So the 3s would be much easier for it. The 3 looks like this. I think this is a 3. Yeah, I think this is maybe a 3. And you reinforce it and you say yes. And it gets all these. And so again, you can see down here, it might have trouble with this 7. It might think it's a 4 or something because of the slash through it. But anyway, it's reinforced that some differences are meaningless. The ways that these 9s are written, the angle is meaningless. And the neural net eventually gets that the angle doesn't really mean anything until it becomes so angular that it's a 6 and a 9. And then that's important. And sometimes 7s can look like 9s as well, right? If we have a little loop here. And so it would know that slight differences in loop like this are meaningless, but when it becomes right on top of each other, then it's important. It goes from a 7 to a 9. So it's not anything special. Categorical perception isn't anything special. This is just what anything that's crunching out data does. There's always noise. There's always changes. Nothing is ever quite perfect. And so to be able to make sense of our world, we have to say, like, this is not important. What's important are these factors. And we focus on those factors. And from there, we get categorical perception. Let me jump back really quickly. So this is more like the natural regularity hypothesis that I told you about in the last lecture, which is something that I adhere to as well, the natural regularity idea. So what it is that we're doing when we're saying that these things don't matter and these things do, the things that do matter, those are the natural regularities that we pick up on. The information is there. We just have to like dust off the things that don't matter and really hone in on the things that do matter. And those are the natural regularities. Okay, so general acoustic theory is the counterpoint to the motor theory. And this just says that the acoustic signal is like totally good enough. We don't need the motor system for help. I mean, first of all, we have people that are totally mute, or people that have had surgeries, people with birth defects who cannot speak correctly, and yet they understand language perfectly. So there's another tick in the box against the motor theory. The acoustic signal is totally sufficient, right? We don't need the motor system for help. I don't know if you know about this pencil study, but I'll tell you about it. So if you hold a pencil in your mouth like this lady is, you end up smiling. I've got a pencil here. I've got a pen. So if you hold a pencil in your mouth like this, you end up, and you say like, don't let it touch your lips, you end up smiling. And then if they say, hold the pencil in your lips and don't let it touch your teeth like this, then you end up frowning. Kyle. So they don't tell the people to smile or frown. They only tell them, hold it with your teeth, don't let your lips touch it. Hold it with your lips, don't let your teeth touch it. Right? And so then what they do is they have these people that are holding the pen or pencil in different ways, read different comic strips, and then they rate how funny they are. And the first experiment into this showed that people who are holding it like she is thought that the comic strips were significantly more funny than the people who held it in the way that it makes them frown. And this was a huge thing. It was really big. It like shook up the psychological world for a little while. And then somebody tried to replicate it, and it did not replicate. And when I was a graduate student, tried to replicate it in a class that I was teaching, and it didn't replicate there either. And at first, it was taken as evidence that the motor system is influencing our emotions. If you can make the body smile, even though it's not happy, it's like a picture for one of those. Why does this always happen to my brain? One of those photo repositories, right? Like Getty Images. So she probably is actually smiling in this one. But if you can make the body smile, even though it's just doing something passive, like holding a pencil, then your emotions will respond to that motor signal that it should be happy. If you can make the body frown, then you should push the emotions into what's typically in line with a frown. And this is just like the motor theory of perception, right? But it doesn't replicate. It doesn't make people happier or more sad. It doesn't make things seem funnier or not as funny to them. We've also seen that there's categorical findings with totally non-speech stimuli for humans as well. Not just, how dogs can recognize speech, but we know that recognizing a musical tone for musical experts is somewhat categorical. So if you have a mistuned string on your guitar, but it's close to an A, it'll sound like an A. I mean, when it gets a little out of tune, musical experts will also know, ooh, that's kind of flat. But once it gets in a certain range of acceptability, it's acceptable. And they've got categorical perception. So it happens with non-speech stimuli too. So we can also use, this is, not necessarily going against the general acoustic theory, but we know that sometimes we're in noisy environments. We know that the acoustic signal is sufficient when there's not noise. Or at least the general acoustic theory, which I ascribe to, says that it's sufficient when there's not noise. But when there is noise, we can also use visual cues to help us figure out what's going on. Not motor cues, but visual cues. We can use other perceptual modalities to figure out what people are saying. And then also, if you took 205 or 367 with me, remember the McGurk effect, where speech perception is based on the auditory cues that are coming into you and the visual cues. And if they're not in line, you end up seeing something in between. So remember our ba, da, ga experiment. If you see ba, but you hear ga, your perceptual systems are going to average the formant that's going down and the formant that's going up into a formant that's flat, and you'll perceive da. And that's true for this as well. If you see, if you see, so this is not exactly written quite right, but you have a happy face that's paired with a happy voice, and you perceive it as happy. You have an angry face paired with an angry voice, you perceive it as angry. But if you have a happy face and an angry voice, you perceive it almost equivalently to a neutral face, neutral voice. Similarly, an angry face, happy voice, you perceive it about the same as a neutral face, neutral voice. So it works with speech sounds. It works with tone of voice and emotion perceived. It also works with the size of objects. So you can have the sound of a beach ball hitting the ground, but show someone a tennis ball, and you ask them what size the beach ball was, and they'll say that it's about, the size of a small basketball. So they're conflating this auditory information and the visual information together. But again, none of it uses the motor information. It's all based on just perceptual things. So we don't need to appeal to the motor system for this. It's all information that comes in either through the ears or sometimes the eyes, but the perception is good enough. And the categorical perception, that's just what we do. That's how the brain works. That's how we make sense of the world. So, evolution is real. I'm not saying that speech isn't special, and it's not we didn't evolve for speech because I don't believe in evolution. I do. I totally do. And it is good. It's great. I'm not trying to put down speech either. I'm just saying that the whole idea of speech being a special case, that there's all this stuff that we've evolved for speech, it doesn't really hold up. In fact, I think the story is a little bit better when you think that we have this amazing ability, which is speech, but the brain is really amazing, more amazing than the ability to speak, because it does this kind of categorical perception across all domains and allows us to hone in on important things and learn and create new things. And also to change what's important when something becomes not important anymore. Think about cochlear implants. When someone had perfect hearing, normal hearing, and then it's been damaged and they get a cochlear implant, at first, they have no idea what to make of this new information coming in. But once they've worn it for 6 months, their perception of words has increased 2 or 3-fold. Once they've worn it for a year, they're back up to about 75-80% correct. And so it's really great what the whole system, the body system, the mind-body system can do with this information coming in. We don't need to say that one thing is special. And we don't need to say that the motor system is what's governing it all. There's really amazing findings just on perception and just with what the brain can do with brain plasticity that are so fantastic that don't need these kind of strange explanations. So all right, good thing that was my last slide. It was a good way to end. All right, so anyway, that's the class. There's a quiz after this, over these two, there's knowledge checks for these two. There's a quiz. Go ahead and take that. There is a final that's going to cover 6, 7, and 8. And then modules 6, 7, and 8. And then there's also an optional cumulative final, which will replace whatever your lowest grade is. If it is your lowest grade, it gets dropped. So feel free to just not study for it and take it if you want to. Though if you did poorly on one of the previous exams and you want to try to make it up, do study for it. But whatever your lowest exam will be dropped. If you don't want to take the cumulative final because you like your score, once you're done with the third one, don't. Just consider your semester with this class over. But you can absolutely feel free to take the optional final with as much or as little preparation as you want. It's not going to hurt your grade. It can only help. So, okay, again, hopefully you enjoyed the class. Like I said, I really enjoyed teaching it. So, and also hopefully you take these skills and apply them to your future career, especially some of the things we've learned with Prot and Audacity. Those are things that you can do in your office when you're an SLP and take a look at signal to noise ratio, harmonics to noise ratio, signal to noise ratio. You can look at the where the formants are, see if maybe that's what's causing one of the speech difficulties is maybe someone speaking and they're putting their formants in a strange place. So then you can think back and maybe try to figure out what's causing that formant to be in the wrong place. You can also look at the bandwidth of the formants and see if maybe that's an issue as well. All right. Well, I will perhaps see you in a future class.